Just want to mention about the possibility of using Antares for solar system object. So actually, we're actively working with a downstream broker at the Northern Arizona University called Snaptin. So we're brokering some of most of the step tagged solar system object alerts, so they can do further processing. But in the meantime, we also provide some solar system alerts or streams that you can use if you want to do your own quick and fast analysis of those solar system objects. So if you go to antares.norlab.edu, you'll see this query page. So the way you can find out those solar system streams is you can see here from the text, you can see the solar system streams is here. And if you are wondering what the text means, you can go to the tag web page. So it's here, you can see the tag here. And then it will explain you the meaning of each tag. So you can see here, there are like in Wiki, they actually try to associate their alerts with solar system object from the manipulation center. So it's kind of like a very broad association. So if you want to be more sure, there's a subset we call the SSO confirm. Is they are happen to be smaller separation from the predicted position from GPO horizons. So that's how we get all those alert streams. And then if you look into detail about those locus, you'll see that there's actually a CTF underscore as its name. And that means the nearest solar system object name. So you can see from here. And then if you are interested in using Time Toolkit, you can actually also use that to do the query. So if you go to the Antares add-ons, and then you'll find there's a place you can view text, you can do the queries there. So I think the most powerful way of exploring the light curve or database of Antares is using our client API and then going to integrate with our data lab online source. So you can go to the data lab and launch Jupyter Notebook there. And then you can go to the default directory. You'll see it comes with a default notebook example, how to do the source system object. This notebook is also uploaded to the Git repository of this workshop. So I'll just walk you through this notebook to show you how to exploit the entire database for the moving object, the source system object. So first you need to import the Antares client. So all these packages that are installed on the Data Lab Jupyter Hub by default. So you don't need to do any installation, you just need to import them. And then you can query the Antares database. So here we use a particular example called Lundia. Its distinct number is 809 in MPC. So you can see here, you just say, okay, I'm going to query the properties of the locus. We have this CTF associated source system object name 809, and then it will return you the query. So just for your information, at the backend of Antares, we are using Elasticsearch as the NoSQL database. Sorry, that might be wrong. We are using a search for the other database, so you can easily query all those informations. So this is the query that we are using for the Elasticsearch. And then once you have done that query, you can extract all the light curve information. So here I try to extract the light curves into G-band and R-band. So we got the date, magnitude, make error. So you can see here for all the locus, and then we try to go through each alerts, because remember that whenever there's alert sent in, it will have some history with it, but those history doesn't come with, so it's trying to do some measurements of the same position of the sky. But that cannot be the asteroid because it's moving. So we only care about the particular timing of this alert. So we want to make sure that this alert is associated with the asteroid or the moving object. So we want to say, okay, it's got to have this name. So make sure it's associated with that moving object. Then we got the date, the magnitude, and its error in the different filters. All right, so we got those light curves in our hand. We can plot it just like this way. So you can see the light curve varies. So here, the x-axis is Julian date, y-axis the magnitude. The green point are the G band, and then the red point are the R band. Okay, so now you got a light curve. And there's a particular reason we choose this particular asteroid because it's a binary asteroid. So we can try to see if we can see the binary light curve. So we know it has a period about 15.42 hours, but there's some trend as you can see here. So we probably want to detrend this because most of the light curve changes here is due to its coming close and then getting further away from the sun. So there's a prediction of that from the GPA horizon. So we can have that prediction and then try to remove that trend. So we get those prediction from GPO, try to interpret those, and then try to remove those parts. And then once we're done, we can plot the detrend light curve and then also try to fold in with the 15 or so hours period. And then here you can see this is the detrend light curve. So it's when the asteroid move, it also depends on your viewing angle. So the eclipse depths can be varying. So we also limit to a certain period of time, so we can better see the light curve shape. So you can see this look like this, like an eclipse in this way. So when we compare that with the more deeper studies, we can actually see a pretty similar shape here. So that's pretty much I want to show you how you can shred the light curve of a source system object using Antares. Of course, here I only show you how to do that for the photometry. In principle, we also have the RN deck. So in principle, you can also get those information and then also get the trajectory of the asteroid moving on the sky. So that's pretty much I want to say. So I'll stop here and take questions.
Okay, Hsiu?
Yep.
Yes, okay. Questions for Hsiu? We have a couple of minutes.
So if there's no question, maybe I can show another neat feature, not really related to the solar system object, but just related to the discussion we were going just before this session. So people were thinking about a way that they can share information, easily. So so now you can also use TAM or Sky Portal. But in Antares, you also have a page where you can take your favorite alerts. So say if you click this alert, you're interested in this one, there's a star here. So you can say, okay, add list to favorites. And then you can also do other things like annotate list alert. Say, okay, this is something I want to go to my favorite favorite object list. You can save that. And then if you go to their favorites, you'll see it's pop up in here. So there are actually many of them. So in principle, you don't really need to go to, if you have some interesting targets, you can just look into your filter and then you can just take them here. And then if you find something interesting, you can also share with your collaborator very conveniently. Yeah, and that's all I want to say.
Okay, thank you again. Last chance for questions to Hsiu, otherwise the Slack channel is available. Okay, thank you again, Hsiu.